for lesson 2.7, one of the things they have you do is verify that you have inverse functions. That means, like, are these two functions inverses of each other? Are these two things inverses of each other? And to verify that, you do f of g of x. That means you, like, I'll get my red pen. It means you take this g of x function over here, g of x, and you plug it into the f of x function. To verify them, you plug one into the other. Okay, so if I plug that in, it would be 3 parentheses, and I'm plugging in all this stuff into that one over there. I'm plugging in this whole problem into this one. So then it's going to say x minus 2 over 3 plus 2. You check f of g of x. You take one problem and plug it into the other, and then you try to work this out, you guys. Do you see the 3 right there on the outside, and there's a 3 in the bottom of the fraction? Those cancel each other out. So then you have x minus 2 plus 2. What happens to minus 2 and plus 2? What happens when you have a minus 2 and then a plus 2? Those cancel each other out. So what do you get? X. Okay, then you have to do it the other way. Then you have to plug the f of x function into the other one and check that one. And if it comes out also to x, then they are inverses of each other. Like, you just check it. So now we do it the other way. Now we're going to do it this way and take this problem over here and plug it into that one where the x is. Try to use my yellow highlighter. So now you do it the other way. It's g of f of x. So now it's vice versa. You take this one and go over here and plug it into this one. So if I do it the other way and plug in 3x plus 2 right here, then minus 2. Look, this one's different. This one, you take this one and go over here and plug in 3x plus 2, and then it says minus 2 all over 3. Now work out that one. So this one was opposite. You took the f of x problem, plugged it into the other one. Now look, at the top of the fraction, there's a 2 minus 2 again. 2 minus 2 is 0. And you have 3x over 3. Isn't that just x? So when you're done, to verify that they're inverses of each other, see how both answers came out to x? You plug one problem into the other, and then do it vice versa, plug the first problem into the second. And if they both work out and just get down to x, they are inverses of each other. So is it always going to work out like so easy like that? No, some of them won't be inverses of each other. Some of them will come out, you're like, well, that didn't work, so that's not an inverse. Okay, another way that you can tell, sometimes they don't give you both problems. Sometimes they just give you one problem and they say find the inverse. So let's say I had a problem that was, let's do one that says, new problem, f of x equals, what do I want to do this time? I'll do x to the third plus 5. This time I'm just going to, see, I didn't give you a second problem. This time I just give you one problem and I say find the inverse. Okay, so how do you do that? Well, it's pretty simple. When you see the f of x, write that as a letter y, first off. F of x is the same as y equals, right? So write y equals instead of f of x. Then you literally have to switch x and y around. Switch, like the y becomes an x and the x becomes a y. So now it says x equals y to the third plus 5. You switch the x and the y, see that? If you took pre-calc, you probably already learned this, but not everyone in here has taken pre-calc. To find an inverse, you switch the x and the y around, then you solve the problem for y. So then you try to get the y alone. You solve for y, try to get y alone. So I would subtract 5. So I'd have x minus 5 over here. X minus 5 equals y to the third. So how do I get rid of the third power that's on the y? Yeah, then you take the cubed root of each side. So the answer for the inverse is the cubed root of x minus 5. And that's called an inverse. So I just found an inverse, so they would write it f. How do you write an inverse? They put like a f to the negative 1 power. That means inverse. Because the original problem was f of x. So this is the inverse function. They put f negative 1 of x equals x minus 5. It's in a cubed root. That's the answer. So see, at the end it was y equals, but I just make it so it's that notation tells me it's the inverse. Yep, this is the inverse answer. So it's f negative 1. Yeah, inverse. F inverse. So they put f negative 1 equals that. So finding an inverse, you're going to have to do that on the assignment. Switch x and y around and then solve it. That's not too bad. That's not too terrible. Let's see. Okay, and then what about graphs? You can actually tell if graphs are going to have an inverse. To tell if a graph has an inverse, it has to pass the horizontal line test. There's what's called a horizontal line test for inverses. There's a thing called the horizontal line test for inverse functions. So, like if I have a graph that looks like this, does it pass what's called the horizontal line test? You draw a horizontal line somewhere through it. Like if I draw a horizontal line kind of like right in the middle like that. Doesn't that hit the graph in a few places? It hits the graph like here, here, and here. So that does not pass the horizontal line test. So this graph does not have an inverse. This function right here does not have an inverse. So this graph or this function does not have an inverse. Because they call it, another way that they say functions that have inverses, they pass the horizontal line test, and they call them one-to-one functions. Like, there's not a y value that repeats. That's what they say. They call it one-to-one. So here's another one. You can do a horizontal line test, and that hit 3 times, so that does not have an inverse. You can also look at points. Like if I had a group of points, and I have like x and y coordinates, and if I didn't have a picture graph, but I had x equals, what if I had like 2, 3, and then 3, 4, and then, I don't know, how about -1, 4, and then 5, 2. I'm just, again, just making up some points. And then they're going to say, they're going to ask if this function like has an inverse. Like, is the inverse a function? Inverse is when you switch x and y. So if you switched x and y around, okay, so this is a function. This is a problem with like 2, 3. If you switch the points around and had 3, 2, and then if you switch this around and had 4, 3, switch this around, it'd be 4, -1, switch this around, 2, 5. We talked about if it's a function, we talked about how x's can't repeat earlier. See, like it had like to tell this is not a function. This original, it does not have an inverse because it had these 4s that repeated. So it's like called the horizontal line test. You actually look if the y's are repeating up here and see, because if I switch it around, then this is not a function. It's not a function because it has these 4s that repeat. So yeah, this original line up here does not have an inverse function because that's not a function because it has the 4s that repeated. So yeah, this original one, yeah, it doesn't have an inverse function because that repeats. That's not a function. So yeah, the original up there, yep, you could say it. They say it's not 1-to-1. They call it 1-to-1. It's the same as like not passing the horizontal line test. It would hit the 4, that 4 twice. Yeah, it's not 1-to-1 because the y had 2 4s. So if you switch it around, then this isn't a function. So it's not an inverse function. Okay, what else do we have to do? Oh yeah, graphing. There's some graphing ones. So there's not a whole lot on inverses, but sometimes they're going to have you graph a function and its inverse. Graph a function and its inverse. We could do that. Like, let's say you had a function. Here's a good one. Let's say you had a function that was f of x equals x squared minus 1. We're going to see if we could graph that function and its inverse. So I'm actually going to give you this function, and I'm going to say, let's just graph it if x is greater than or equal to 0. They'll sometimes give you little stipulations, like just look at this part of the graph. Sometimes in the assignment they give you little stipulations. So we're going to graph this, but only if x is greater than 0. So if you have to graph it, you could make a table if you want. An XY table. Okay, we're just saying we're only going to use numbers greater than 0. So on my table, I could just put 0, numbers just greater than 0, like 0, 1, 2, 3, just a few numbers like that. What do you get if you put a 0 in there? And we have to fill in this table. What do you think? 0 squared minus 1. Wouldn't that be negative 1? And then put in 1 squared. 1 squared is 1. 1 minus 1, that's 0. What's 2 squared minus 1? You guys see what I'm doing? I'm plugging these numbers in. What's 2 squared minus 1? Do you know? Yeah, 3. Good job. 2 squared is 4. 4 minus 1 is 3. And then 3 squared is 9. 9 minus 1 is 8. So you could graph this function I give you, and then let's figure out the inverse and see if we can graph that too. That's what you have to do, like 2 things on one graph. So here, we'll make the graph down here. So you got 0, negative 1, 1 comma 0, 2 is 3, 2, 3, and then 3, 8. That goes way up high then. Okay, so this graph looks like this. I mean, that's close enough, right? I'm just sketching it, so that's good. Okay, now you need the inverse. Well, let's do the inverse. This is y equals x squared minus 1. That was the problem they gave us to start with. How do you find the inverse? We just did one a minute ago. How do you find the inverse? Switch x and y around. Okay? So we need to take this problem right here and find the inverse. You literally have to switch x and y around. So find the inverse. You have to switch x and y. You make the y into an x and you make the x into a y. You literally switch them. So it's going to say x equals y squared minus 1. Switch x and y around. Now solve for y. So how do you solve for y? Get the y alone. How do you do that?
Add 1.
Yep, add 1. So it's x plus 1 equals y squared. Good job. Then how do you get rid of the y squared? The squared that's on the y. What's the opposite of squared?
Square root.
Yep, take the square root. So square root, so y, so this is your inverse. This is your f negative 1, they call it, inverse function. That's how they would write it, f with a little negative 1, that means inverse. Yeah, it's square root of x plus 1. Good job. So now if we had to graph that on the exact same graph, what would happen? Well, again, you could make a table. You could easily make a table. It doesn't take that long. And you can plug in numbers. Remember, you just can't have square roots of negative numbers. You can't like plug in like -5 in here. It's not going to work. You can't have square roots of negative numbers, but we could plug in like 0. We could even plug in -1, because -1 plus 1 is 0. Square root of 0 is 0. We could plug in 0, 1, 2, etc. 0 plus 1 is 1. Square root of 1 is 1. This would be square root of 2. Let's see, what's square root of 2? I need a calculator. It's like 1.4, I think. Square root of 2, yeah, 1.4. And then if I put a 2 in there, let's see, 2 plus 1 is 3. What's square root of 3? Square root of 3 is 1.7, etc. If I put in 3, 3 plus 1 is 4, square root of 4 is 2. See, you can get it. It just takes a little bit. And so then I can graph it. -1, 0 is over here. 0, 1. 1 is 1.4. 2 is 1.7. 3 is 2. Look what happens. Look at the inverse and the original. I want you to see this, how inverses work. Look what happened when I graphed it. You see how they kind of go opposite ways? Another thing you might notice, I want to kind of point this out. Okay, I graphed it for you. I made little tables and everything. In this table, this says 0, -1. Did you notice down here there was a point that was opposite of that, -1, 0? And over here this said 2, 3, and down here there was a point 3, 2. They are literally like switched around, x and y. Inverses, it's switched around. So I could have just switched all the numbers in that table and got, and that's faster, but I just wanted to show you how it worked. Yeah, inverses are interesting. They actually like cross over this, they're like a mirror image of each other. They flip over, it's a reflection over the y equals x line. This dotted red line I just drew in there, it's like they're on flip-flop sides of that, the y equals x line. It's a reflection over that line. Yep, so this line, this red line I drew in was y equals x. See, it's like a reflection over that line. Y and x are switched, so it's reflect. Yep, so inverses reflect. I have it right, it's in the book too. That's the one we were just drawing. Here, I'll try to focus it. That's the one I was just doing with you from the book. See, that's the one we just graphed. See, they flip-flop over this line here. So it's kind of interesting. So when you do your assignment, if they give you pictures like that, like this, see, here's another one. If they give you a picture, the inverse is like flipped over this line, this diagonal line. They're like flipped mirror images of each other side like that. Yep, so inverse functions, they're flipped over this diagonal line. So pretty quickly, like I could draw some kind of shape and you could flip it over that line. Like if I come down here on my notes and draw another picture, let's say I drew, I don't know, I'll just try to draw something like like if I draw something like up here, like this, then I could find the inverse. It would just take a second. I could draw, even if I don't give you the equations, I could figure it out because an inverse is supposed to flip over this line. So if I just drew something in and said, what's the inverse of this? They do that on some of the pictures on the assignment. They just give you a picture and they say, well, what's the inverse of this? Well, wouldn't it be like over here? See, it'd be like on the other side of this red dotted line. So like if this was at 1, 2, 3, let's say, then you'd be over here at 1, 2, 3. It'd be like this. It would go something like that. You know, I'm not perfect drawing it, but it'd be something like that. So you'll be able to look at the pictures on the assignment and you'll see the inverses just flip over this diagonal line. You'll be able to see some of the pictures, how they just flip over the diagonal line. That's what inverses do. So yeah, finding inverses, you switch x and y, and then solve for y, and you can figure out the equations. Sometimes it'll be a visual thing like this. You can just see it. It's on the other side of that red dotted line. So hopefully you're catching on. It's not too bad. Sometimes they just ask you to look at some pictures and say, does this graph have an inverse? Like this one would be no. It doesn't pass the horizontal line test. It's not 1-to-1. They call it also like not 1-to-1. Has to pass a horizontal line test. So yeah, switch x and y to find inverses. So just remember, if it says f of x in the original problem, just write that as a y equals, and you have your equation. Then switch your x and y and solve it, and you'll get the inverse. All right, so you guys have work time. I'll come around and help you.